Workloads protected by VMware are the safest workloads in the multi-cloud. Private cloud, public cloud, any cloud. Stronger, with distributed protection to the API and everything east-west, inside, and cross-cloud. Stronger, with 3 layers of detection, trusting nothing and seeing everything, even the best hidden bad actors. Stronger, with an SE Labs AAA certified advanced NDR that brings the multi-cloud together for the win. You've got workloads, we've got security. VMware Security. Simply stronger. Visit securityweekly.com/VMware to learn more.
Welcome back to Enterprise Security Weekly. Throughout 2022, CRA's Business Intelligence Unit will be releasing research reports on the top topics across the security industry. Our first report will be on third-party risk and the supply chain. Very topical. To participate in the survey, please visit securityweekly.com/third-party risk. The results will be shared in our third-party risk e-summit in January. All right, and for our second interview today, this interview is sponsored by Riverbed, and Vincent Berk joins us today to talk about securing the invisible, how holes in your visibility fabric form the cracks where hackers hide. Vincent is the CTO and Chief Security Architect at Riverbed. He sets the vision and strategy for network performance monitoring within the cybersecurity business unit there. He came to Riverbed through the acquisition of FlowTrack, where he was the founder and CEO. Vincent also has a PhD in machine learning and large-scale data analytics, which could tempt us into some sidebar conversations. Welcome to the show, Vincent.
It's good to be here. Thank you.
Yeah, absolutely. And we were just talking about your background. Maybe share a little bit with us about how you meandered into security in the first place.
You know, that is actually the crazy story, because I got my PhD in machine learning in the early 2000s, which is when pretty much everybody believed we were in a machine learning AI winter, right? Like there was just, there were algorithms and there were ideas, but it wasn't really moving the needle in terms of sort of application use cases. And to me, it was interesting because when I was doing my early studies, I was always a high performance computing guy, right? Like it's all about scale, right? Like the problem in the 1990s always was, we can't execute algorithms fast enough. And therefore, if we can parallelize them arbitrarily, right, then the idea is that if you use a lot of computers, you can get that job done faster. And so I sort of rolled into machine learning from that perspective. The problem is in the early 2000s, when you got your PhD in machine learning, you might as well not have gotten a PhD at all, because there was no work for that. And that's how you kind of roll into cybersecurity. So I started out my career trying to see how we could use diverse signals from cybersecurity and bring those together and sort of make sense of it. And what I mean by that is, right, like, if you think about things you might see on the network, and then you combine those with logs, how do you reason about those things and bring them together and come to a single conclusion? I found that an interesting problem back in the day. So that's how I rolled from machine learning and data analytics into the cybersecurity space.
And little did you know, you didn't have a crystal ball, but you definitely stumbled into something pretty good there. Well,
and I think that's it's super opportune to think about that, like in today's day and age, because the network environment because I spent years as an incident responder. Actually, that's the other interesting sidebar to that. I started a career trying to figure out how to bring these diverse signals together and reason about them. Right now, that's not so much that something that people were thinking about initially in the 2006, 2008 timeframe. But then I spent years as an incident responder. I actually doing operational security work. Then I went into product, where the very first problem one tried to solve was a problem of scale, right? And we know that from the major SIEM systems as well, mm-hmm. right? Like how do you bring these enormous volumes of event data together just so that we can search on them? And I was, of course, in the networking space. We were doing that with network flow data and packet data, right? Same sort of scale problems persist. And I think that what you're hinting at is the evolution we went through, sort of from how do you capture this much data and make it, searchable, presentable, define rules and reasons on it, all the way to how do you combine two different signals that are wildly diverse. And if you'll let me, I'll give you an example of what I mean by that, right? Like, for example, you might get 1,000 or 10,000 failed login attempts to a SQL server, right? That's obviously some kind of brute force attack or some script having gone awry. And you can you can pluck this apart in a SIM. You can figure out whether the same username was attempted, different usernames, passwords, and what have you. Right? Those are 10,000 signals. Now, there might also be one that was successful, right? You get through. They had a successful login on that brute force attempt. And that's probably is going to come at the end, right? You stop trying passwords when that happens. Those 10,000 failed ones are not nearly as important as the one successful one. And that one successful one is ever so more important because you had the 10,000 failures before, right? And those are, to me, very interesting data analytics problems, right? And we're doing that today with a lot of brute forcing. And we only now are starting to see people building in like, hey, you know what? This is by nature interesting to humans. How can we automate that stuff? So if you're asking about a digression into machine learning and kind of techniques to apply there, right? I think that's sort of where the state of the art is going, and where we need to start, where we need to start putting our investment.
And you really hit on one of the things that's really bothered me about the way a lot of security tools are designed and how they report things. In that, when you tell me there's 10,000 failed logins and one successful, to me, that's two events. It's the first event was somebody trying to get in, and the second event was they got in. Like, I don't care that's, yes, physically in the log, it's 10,000 different lines, 10,000 different events, but any rational person who has a background like yours and has done IR, has done threat hunting, and this, by the way, happens over in vulnerability management as well. There's a lot of noise that's just duplication of a single signal. If I have an old version of Java, it's entirely possible with a 3-year-old version of Java, on multiple systems in my network, I can get 200,000 vulnerabilities out of that. And even today, a lot of these systems won't tell me, oh, you got an old version of Java. They'll tell me you get 200,000 critical vulnerabilities, and you have to spend a couple days, exporting it to Excel and playing with pivot charts to figure out, oh, I just have an old version of Java. So where are we in getting towards that, where kind of translating this data into something that makes more sense to humans, I guess?
So I think that's a really good question. And I'm going to probably anger a lot of my close colleagues and friends at other businesses that are working on this problem. I'm going to say we're not very far. But I'm not saying that because the techniques we're using aren't working, because I think we're way, way further than we were sort of 20 years ago. I think one very good example to draw, and I don't know how familiar you are sort of with convolutional neural networks, but if I give you 10,000 photographs and you go through it, you'll have no problem classifying what every picture is, right? Like, that's a tree, that's a car, that's a, what have you. And it doesn't really matter to you whether or not, right, there's 3 cars in that intersection, right? And you recognize the intersection. It doesn't really matter to you whether it's, night or day, whether it's snowing, whether it's the light is off, or whether the photograph's blurry, right? Like, that might be happening, or there's some random noise, or you get a black and white version of it. You probably still recognize 3 cars in an intersection. Right? Seems straightforward because we're trying to do all this computer vision stuff for self-driving cars. Okay, so it's easy. Your brain's a neural network. We take a neural network for image recognition. We should be straightforward to do that. Well, it turns out it's really hard, right? So we tried that. We tried training neural networks on large databases of photographs, and just a little bit of random noise can completely destroy the classification we see. And the same exact thing is happening in cybersecurity. And I'll give you the example, I'll carry it one step further. So how do we approach it, right? What we're doing is we're still using all manner of traditional image processing techniques to try to rotate the image that's in front of us, or do segmentation, or try to identify first the moving objects and then to try to do image classification on that, right? And we're trying to stack traditional techniques but the more machine learning style techniques that come up to sort of a conclusion of, yeah, this is an intersection with 3 cars, and then you put a truck in it and the thing's still confused. Why? It's because we are putting a lot of rules in that inference to make use of that little bit of sort of machine learning brain power we have. And the same thing is happening when I'm looking at logs. And I'm using logs because most people in cybersecurity are really familiar with that, right? There's a lot of good tools, that are log collectors in which we create rules and we, use AI. My background is, as I described, behavioral analytics on network traffic, and that the story there is identical. Right? It's almost exactly the same. The point being is that when we look at the kinds of rules we're creating exactly the rule that you are describing. These 10,000 failed login attempts should be together considered one event. And then the successful one, if it comes pretty rapidly in sequence, those things are related. And this is a really bad sign. And we are only now seeing the best security analytical systems start putting those sort of things together. And what I mean by that is you get sort of these fused rules, like rules, you can create one rule that grabs all the failed login attempts. You can combine it with a successful one. And then I'm still putting in that logic that you would call blatantly obvious, right? Like 10,000 failed ones, and then a successful one coming from the same IP address. Well, this is probably not good, right? You know that. And if it happened in a different order or in a different service or a different, the signal was different, you'd still see it and be like, I know what happened here. And we are still in a place where we're effectively creating these rules almost by hand to recognize it. We're still almost at the level of using machine learning with aided by expert systems technology, right? Like, so I think, again, to say we're not very far simply means to say we can go much further in the years to come, and we've come a long way, but there's so much more to do.
So I have a follow-up question on this for you. Would you say that we're still lacking in algorithmic improvement, or are we simply lacking in the creation of the rules? And I know, that's not a true ML term, but the creation and understanding of how to apply the correct quantity. Like you mentioned the 10,000 failed, 1 good. That's kind of one scenario. Are we just lacking in our enumeration capability of all possible scenarios? Is that where the gap exists?
So it is algorithmic in many ways. The problem is we call this generalization, right? So if I show you 5 pictures of an apple, and then I show you, and I tell you this is an apple, and then I give you another apple, and you look at it, you probably be like, oh, that also looks like an apple, and right, and you'll be able to generalize, right? You say like the thing is round, the thing is probably yellow or green, and the thing's got a little stem on it, and maybe a leaf, right? Whatever, it's the size of my hand, right? So you quickly sort of build out an understanding of the thing called an apple, right? When we're in machine learning, what ends up happening is, well, if I show that apple a number of times, I might get something called overfitting, where what I'm looking at is this apple, and I'm only I'm gonna do 100% correct on the 5 apples that I've seen. But if I see another apple, I can't generalize to it. And I think that this generalization is where we're struggling. And the reason I'm pointing this out so much, goes back to what we were earlier discussing, right? Like if we see the evolution of threats that are happening in the environment, and we see the way that our networks are evolving, which is effectively, right, we're a lot more remote, but we are also building way more complex services, right? Complexity is just a factor that ends up happening in computing in general, right? And started a long time ago with, well, I wrote a library to sort data in a binary tree. Well, that's good. Someone else can use it. Now they don't have to write it again. So they will use my code, right? They use my library, and they build another library that has 5 other sorting mechanisms in it. And that becomes a bigger library. And then that ends up being included. And so complexity is sort of a thing, right? Like we're able to build better cars today because we're able to optimize technologies we've built for cars before and build upon that. We do the exact same thing with software. We do the exact same thing with networks. We build more complex things. Like airplanes are more complex now than they were a long time ago, right? When we first started flying. So as we built this complexity, What ends up happening is we lose the ability to reason about it generically because indeed your search space gets so much bigger, which is exactly what you were getting at, right? Like, we can't enumerate all the possible ways in which the bad guys can hide. No, that's exactly right. We can't, and we never, ever will be able to enumerate all the ways in which we can compromise a network or we can get in, because as networks get more complex and evolve, and as software gets more complex and evolves, there'll be new ways in which it will break, right? Ways that may seem somewhat familiar to something we've seen before, and that we're only going to be able to catch when we can generalize the problem a little bit better, right? And that's where I think a lot of the growing in AI and ML in the cybersecurity space has to happen.
So, in continuing the image recognition, examples there, does cybersecurity have a lot of blueberry muffin problems, or just a few, or is that something that you see a lot?
I think they're not easy to recognize, I would say, right? Because we are making good progress. But one thing that ends up happening a lot in my line of work, right, which is really interesting, I didn't think that would happen, is Riverbed has traditionally focused on WAN optimization. It today focuses a lot on visibility, network troubleshooting, data collection on the endpoint, data collection on the network to try to figure out why a user experience is bad, what have you. Surprisingly, we get called by security incident responders all the time, right? This started when we were acquired into Riverbed, and it's still happening today. And the questions always are, right, traditional defenses have failed. Someone got in. They got in deep, they got in wide, and now we need to know what happened, where the traffic went, from what, where they came from, in the various ways. And it's an incident response, right? And that affords me a fairly good view of how incident response and also traditional cybersecurity is, and I start to see patterns there, right? And what I mean by that is in that incident response process, we tend to go through, right, what Riverbed collects is, packets and logs and endpoint data, but not endpoint detections, right? There's a distinction there. We could talk about that. But the point is that the tools are forensically recording stuff that happens on the endpoint and the network and the server and what have you, so that we can go back later and say, geez, why was it slow or why was it breaking? Except that when you record that data, you can also exactly see what the bad guy did and how they did it. And if I look at that, right, with a background in incident response, I start to say, well, the SIM didn't pick it up, or the SIM picked it up, but there were 50,000 events just like it that had nothing to do with that. So it wasn't very well able to generalize this, right? So is this a blueberry muffin problem? Yeah, absolutely, right? Like we have gotten really good at detecting some things really well. And I say that because my background, right, like what FlowDrag did was we were a company that was just building tools to find those 10,000 failed logins, but in the network traffic, right? Like the behavior of the network traffic, and then alert on that. Now, what is the problem with that, right? When that exact pattern happens, the detectors will catch it and will warn you. But it took how long to build those, right? Some of these rules take weeks to build and evolve to the point where they're reliable detectors. What is the change in technique that the adversary has to do, right? Use different IP addresses, change the timing around a little bit, figure out if, spraying different host names, right? Like there's a simple, like the cost on the attacker is way, way lower than it is on the defender still today, right? And I see that in my daily work. And that's that blueberry muffin problem you're talking about. Yeah. If the hacker behaves just exactly as we built our detectors, AI or no AI, then we're going to find them. If they just ever so minutely tweak it because they know they're being watched.
Yeah. And let me shift things, maybe zoom out a little bit, take a bit more of a macro look at the process here. From a threat hunting and IR perspective, I see, and to kind of further go into Tyler's question, three gaps here. The first gap is just visibility in general. Do you have a sensor to gather this data? I call that the system saw it happen. and you saw a bunch of vendors coming out of the SolarWinds, the whole SolarWinds debacle, saying we caught that, and that's great that your system saw it, but that doesn't mean people saw it. So that's the next gap. A human saw it happen. It's great if a system saw it, but that's just step one. A human has to see it to, take any kind of action unless everything's fully automated, which I don't think most of our IR teams and businesses are fully comfortable with at this point. And then the last step there, and really I see this when doing postmortems on breaches and studying breaches a lot, is most of the time the technology worked fine. It wasn't the technology that failed. It was people and process that tend to fail. And that third gap, that third level, is a human both saw it and understood what it was and what to do with it. So we see a lot of cases where, back in the Target is a great example where FireEye caught the bad guys. Somebody from FireEye called them up and said, "Hey, you've got a problem," and they're like, didn't do the right thing with the information. So I think those last two gaps, making sure a human sees it and making sure a human knows what to do with it when they see it, which I think is much more on the enterprise side, training things like that than something you can put on the vendor. But to some extent, the vendor can help with both those two latter gaps. I think making sure people see the right things and see them in the right context that they know what to do with them.
So what I think you just did is you just teed up an hour's worth of discussion and market analysis. So I'd love to have an opinion on all of this. In fact, I do. But let's take this in reverse order, right? Because the first thing you're pointing out, or the last thing you were pointing out, the first thing I'm going to react to is the process and procedure problem, right? There's an enormous amount of process and procedure that is missing. And it is exactly what you say. It is an educational issue, but it is not just on the people need to get better degrees or better training, right? Because if I've stood up about a half a dozen or so cyber hunt teams over my career, helping groups do that. And the first question always is, can we outsource that? No, you can't outsource it because you want someone who is really knowledgeable on your enterprise and your infrastructure too. Can we combine this with the NSOC? No, you can't. You really want to make sure that the guy that does that is out there hunting and doesn't have incident response, right? So you get to very rapidly to someone who is skilled and has seen a few things. And what that means is exactly where you're at with your question on process. Okay, we found something. It was made aware to us. And I looked into it, but I didn't recognize it for what it was. I followed the book. I re-imaged the machine. We're all done here, right? But little did we recognize is that the compromise happened because domain password was compromised. The next machine falls right for it. Hackers now a little bit more careful, right? It's really, really, right? The worst thing to do when you eradicate, a bug infestation in your house is only spray half of them, because very rapidly they'll evolve to not care about your pesticide anymore. And that's exactly what you're doing, right? So that process thing, if you found something, is this indicative of something bigger that is not ingrained in enterprises, and it needs to become that way, right? So that's that process piece. The other piece you talked about is the question of making the human aware or fully automating. I only have one comment about that. The comment is very simple. There is no better anomaly detection and correlation engine out there than the human mind, right? And so no matter how good we want to make our machine learning algorithms, right, we're still at the level of a snail, right? Like we're not very good in making AIs, right? We can barely navigate, right? So at some point, when we build software and when we build tools for assisting cybersecurity, we need to recognize that it is the most important task we have there is to make use of that really powerful correlation engine that is the human. And how do we do that? We have a responsibility as tool builders to make sure that we surface those things in the right format and the right way to consume so that human brain can do that correlation to the best of its abilities, right? That absolutely means that if you have 50,000 of the same alerts, yeah, you can say you saw the SolarWinds hack, but it doesn't really mean anything because nobody was indeed aware of it, right? So this is a human-machine interface. How is software consumed, and how do we make good use of the human in the operations? That question is absolutely something that's right on the vendor. And then finally, you said, well, it's all useless if you can't see there, right? And that gets right back to when I was asked for a title here. You so aptly read the whole thing out, right? Like there's the cracks in the visibility where the hackers hide, but that's actually, it's a little bit fastidious, but it's absolutely true. And it's not just get visibility, but it's get angles of visibility. And I'm going to give you one example of what I mean by that. Okay. When the military is concerned about a theater, right? Let's not pick on the Canadians coming from the north because I'm at the northern border, but imagine they are, right? What do we do? Do we just get like one guy with binoculars and put him on a hill and say, call me when the Canadians start mounting up, right? No, we don't. What we do is we put the guy on the hill, and then on the next hill, we put another guy, and then we get a radar, we get an infrared, we put a satellite up there. We're going to fly an airplane overhead. And I know very little about military technology, but one thing I do know is that we seem to have a lot of visibility technologies in the military. We're using different types of cameras, sonars and radars and what have you, to observe one and the same environment. And from different angles, things look different, right? And so when it comes to your comment about we need to gain better visibility, I say we need to gain better visibility and diversify our visibility. So what does that mean in practical terms? In practical terms is logs are not enough. They're absolutely necessary, but they're by no means sufficient, right? And so think about other types of data you can collect. And what I mean, the next logical thing is like capture packets. All right, well, that can be helpful, but see about flow data. And often this data is already being collected in the enterprise, right, by the network operators. Think about endpoint data. And I don't mean, EDR data. I don't mean detection data. I mean simple data on what process is running, who is logged in, what is using CPU, who's making network connections. I mean, and keep it forensically. Keep a big data lake on that stuff, or get a product that can remember that, because invariably the question always comes, oh, they were on that system, huh? Oh, here's a process name, and it was using 100% CPU because they were crypto mining. Now, is there any other system in my enterprise showing exactly the same behavior, right? You want that to be a right-click pivot, search for this process name, more than 80% CPU, tell me all the hosts in my network that are doing that, right? And that's what I mean by angles of visibility. So there, in 5 minutes, I think I tried to cover all those three points.
Remarkably well, I might say. Yeah, and you also hit on one of my biggest pet peeves of SIMs and NDRs and security products. At least back in my history working on the as an incident handler, I hated when you'd hit a detection and then it would grab a few packets around the detection and just after it, and inevitably what you would need to understand the incident would be the 2 or 3 packets that came before the detection, but you never got those packets. So it was always frustrating to me to not have the full flow data or to not have the full packet capture in a lot of those environments. And that's where I ended up going after full packet capture. Even if I just had a rolling couple of hours worth, it would help me kind of find those smoking guns and understand how some of these intrusions were working. So I can totally relate to that.
Yeah, I think that is by far the story I hear the most in the field these days. And there's a point to why I'm going to reiterate what you just said. It'll come quick. So here's what I see. So I had that exact same frustration. So what I used to do, right, when I did this kind of work, we still could get enough hard drives, and the link. When you're on a T1 link, at that point hard drives were still big enough, and you could keep a few days of raw packets. There was also not a lot encrypted yet. these days, links have the growth of link speed has by far outpaced the growth in hard drive speed, not capacity, but hard drive speed. So it's gotten a little harder. The funny thing about this is that when I joined Riverbed, I was in the flow business. I wasn't in the packet business. And I say, oh, you got these packet appliances. That's really interesting. What are you doing for security with that? Oh, we don't use them for security. I say, that seems odd. Like, because you're capturing packets, petabytes of packets. And you're not giving us, no, I don't think we have security use cases. So I called a few customers. I said, are your cyber guys aware that you're capturing these packets? Oh, yeah. They got their scripts set up. I'm like, what do you mean? And then I started discovering that I would say 60% of Riverbed's customers, the cyber guys had already figured out that there were network performance appliances capturing packets. And they had really simple scripts that kick off to an API that said, grab me, 10 minutes before the incident and an hour after with these IP addresses and ports and make that into a capture file. And, these appliances were doing that happily, right? So I actually discovered that the cyber guys were already doing that, right? Which is why Riverbed's now putting a lot more emphasis on share the tooling, because it is useful for both operations, performance operations, and security.
It's a great anecdote because the exact reverse happened to me. We got a SIM because we had to be PCI compliant, and very quickly the rest of IT figured out, hey, the security group has this system that has all the logs poured into it, in one system. And so anytime there'd be any kind of outage or anything like that, they'd co-opt us to do root cause analysis and figure out why systems went down.
Yeah, absolutely. And I think that's also, I guess, if there's any real point to the discussion that we're having today, right, is that, sharing that telemetry, whether it's logs or packets or flows or endpoint data, event data from the cloud, right? Bringing that data, know you own it, make it accessible to both the teams is going to get you a lot of bang for the buck, right? Like if you are going to buy a flow or a packet appliance and then, the security guy is going to do the same thing, then effectively you're going to get half the recall for the dollar spent, right? Like you share that stuff, you can get a lot more angles of visibility. The other thing I'll say about that is that as you're making selections for tooling, think about which tooling has that forensic capability in it, right? Like a lot of tooling that we're buying is blinky light goes off when we detect something we know how to detect, but we don't store the raw data. And raw data is expensive, and I know that, but invariably, the most insidious advanced persistent threats were mostly evidence-free. And you need all the data you can to figure out what happened. I call that full fidelity. And with that, right, is the point that comes with that is that, listen, as you buy tools, full fidelity tools, don't spend all the money on detection tooling, but think about visibility tooling as well, because the time will come when you need to answer a very critical question that cannot be answered by simply looking at the blinky red light only.
100%. And that's an excellent place to end it. Vincent, thank you so much for joining us on Enterprise Security Weekly today.
It was a pleasure to be here.
Make sure you visit securityweekly.com/Riverbed to learn more. And we'll be back in a few moments with the weekly enterprise news.